Alrighty everyone, welcome to day 12 of Advent to Code. I'm getting quite a late start today. Today was my last day of finals for the semester, so it is late already. But anyways, let's get into today's problem. We are going to be mapping the positions and velocities of the moons around Jupiter. The math behind this one confuses me a little bit. I don't quite understand the math, but stick with me. So we will be tracking the 4 largest moons, and our input is their current position in 3D space. So actually, if I pull up the input here, you'll see here's the input. This is their position in 3D space. Each step, which is a progression of time, is one step. So each step, we have to recalculate both their position and velocity. So for their words on the site, within each time step, first update the velocity of every moon by applying gravity. Then, once all the moon's velocities have been updated, update the positions of every moon by applying velocity. That part makes sense because that's how you would apply velocity. You'd calculate the velocity and then apply the position. To apply the gravity, we have to consider every pair of moons. On each axis of x, y, and z, the velocity of each moon changes by exactly plus or negative 1. To pull the moons together. That part's pretty clear to me. So I will try to do this one at a time. Luckily, this one we have a good example, so I can kind of check early on if this is actually working. But first off, let's just pull the inputs in. So file util, load our file, and this is res day 12, and go from there. All right. So here's our inputs. So we will actually need a vector 3 today. So we've been using vector 2s. Let's actually just go back here just because I'm lazy. We'll grab our vector 2i from the past few days, but we'll change it to a vector 3i. And what we'll do is we will add in a z to our vector 3i. So int z, if I could type this dot z equals z, and there we go. We got a x, y, and z in our vector. Let's go ahead and apply the z here, and go ahead and add the condition for our z in here. So this is actually going to be a z vector 3i. We don't need the day 10 bits. Don't need that. Don't need that. Okay. I will remove the hash code for now because I don't think we're going to need it, but I'll keep the rest of it. So now we have our vector 3i. So we are going to, I guess, hold these in an array. So these will be the moons. These are the vector 3i's. There's going to be 4 of them, and we'll do that. Okay, so now that we have our moons here, we need to read the input in and convert it to vectors. So we're going to have to go through each line of our inputs. Whoops, size. And convert it to a vector 3i. So the input is this. So let me copy this, put it here. So string moon position is going to be equal input and get I. Okay, so we have our moon position. Now we got to basically extrapolate the position here from this. So luckily for the int x is going to be pretty easy because this will just be moon position dot substring of 1, 2, 3 of 3 to moon position dot it's index of the first comma. Okay, and convert it to an integer. Easy enough. Okay, so there's our x. So the y is a little easier, but we have to say the position of the y, the index. So y index So we need the index of the y. This way we can do the same thing here. Instead of x, this will be y. This will be the substring of y index plus 2. Yeah, plus 2, and then we're going to go to the index of that, but the one that's after y index. Copy this once more, because we're now do this for the z, and the same exact thing. And that should, oh, we're going to actually do this for moon position dot length minus 2. I think that's what we want. I think this will give us the x, y, and z we want. So let's convert this to a vector 3i. So this is going to be moon equals new vector 3i, x, y, and z. Let's then set the moons of I equal to the moon. And I'm just going to system out print line the moon just to make sure that it correctly reads it in. So let's give this a run. Let's not run day 11. Let's run day 12. Let it build it up. There we go. So we got a negative sign for the format of the z. Oh, because it's not minus 2, it's just the length. Minus 1. Yeah. There we go. There we go. All right, and so it's read it in 10, negative 10, negative 10, negative 13, 5, 5, negative 9, 3, 8, negative 16, and 1, 3, negative 3. Good. So all right, we've read them in correctly. We're all good there. So I'm actually going to skip this a bit, make it a little bit cleaner. And there we go. So now we have correctly read in the moon's positions. So we will also need an integer to hold the step. Started at 0. And then we will increment the step every time. But to start, we just need to find the first velocity. So whenever, this is a helpful tip for anyone, whenever you're doing something with programming, something that has a large loop, it's of just the same thing over and over and over again, the easiest way to start is just program one iteration. Don't worry about the loop at all. Just get one iteration working. Because therefore, if you get one iteration working, the rest of them should also work. So for the process of just calculating it once, it's each pair of moons. So I think that means we need a double for loop. So for int I, 0 while I is less than moons dot length I plus plus. So I think we need to calculate each moon and its position to the other. I think that'd be right. So what we will do is we'll do this, and then we'll just check to make sure that the moon is not the same moon. There we go. All right, so now we're gonna do the calculation. So what it says is that the velocity will increase by 1 or decrease by 1 depending upon that moon's velocity on that axis. Let me rephrase that. So on each axis, the x, y, and z, for each direction, the x, y, and z, we will compare each axis in those pair of moons. So we'll first compare the x-axis together. Whichever one's greater will increase its velocity on that axis by 1. Whichever one is less will decrease its velocity on that axis by 1. Same thing goes with the y, and then same thing goes with the z. So knowing that, we need to get our vector 2i's, or vector 3i's, sorry. And this is going to be, just do moon 1. And we'll do I, whoops. I, and then moon 2 will be j. Okay. So these are the positions. So actually what we want is also velocities. So this is me moons pause, and this will be moons vels. There's moon vel. So the moon position will equal to that. The moon velocity starts at 0, 0, 0. These will be the moon's position. So this will be moon 1 pause. And then moon 1 velocity will be this. Copy the same thing here. This will be moon 2 instead. Okay. So on each axis, we'll compare and then update accordingly. So, so we'll just do moon 1 x greater than moon 2. I didn't change that to position. X. So if it is, we will have to increment the X on that moon, decrement it on the other moon, decrement it's on moon 2, like that. Otherwise, do the opposite. So decrement that one, increment that one. And this will be just done 2 more times, one for each of the directions. Probably could, I don't know if we can make that better, but anyways. And then the Z, 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 and Z. I don't know why that plus is messed up there. It's messed up there too, and there. Okay. There we go. So now we are correctly updating the velocities, and at the very end of this, let's go ahead and output their position and velocities. Actually, sorry, no. After this, we will then need to update their positions based upon the velocities. So what we're actually going to do is in here, public static void, not static, public void add. We'll just add and we'll call a vector 3i. And we will do this dot x plus equals vector plus equals vec dot x. Basically change this vector and offset it to with what the other vector is. Like that. So now all we have to do is down here, do moon's position 0, or actually just do a for loop. Again. Do a nice little for loop on each of the moons. And just do moon's position of I dot add moon's velocity I. This will change their position based upon their velocity. And what we will go ahead and do is do a system out print line of let's go ahead and do it in here. Sure, why not? Go ahead and output the moon's position. And I'm matching their format they have in the examples. This is what I'm doing right now. Not going to be exactly the same, but close enough. Space equals velocity. All right. So let's see now if one iteration will match what they have. Oh, I need to put in their example input. That'd probably help. Just have to 0, 1 step. That is not correct. -6 is way too high. It looks like it's because this needs to be an else if flipped. Looks like you don't always change their velocities. Let's give this a run, see if this does anything. We should be seeing 3, -1, -1 here. So it looks like it's right just doubled. You know why it's doubled is because we are actually doubling what we're seeing. This is actually doubling each pair. So you know what we can do is start it at I, because this will do, so 0, and it'll do then, if we do it I plus 1, it'll then do 1, 2, 3. We do 1, it'll do 2 and 3. Yeah, okay, so we want this to be then I plus 1. That should stop the doubling from occurring, hopefully. It's right just flipped, because that's -3, 1, 1, which should be -3, 1, or 3, -1, -1. It looks like these are all just flipped. Oh, you know why? It's because they're pulling each other together. So we just need to flip these. I see, because they're pulling them together. So the one that has a greater X needs to get pulled back towards the other one. That makes sense. Okay, so now if I run this, now we should see 3, -1. There we go. Okay, so now we're matching their input. Okay. So now the only thing that's left is to actually add in the steps. So that's pretty easy. We just do a while loop. So while step is, they do 10, so we'll do while step is less than 10. 11, just because they go to 10. So this system out will be moved up here. So this will be a system out print line, matching their inputs after step, or after step. Steps, print stuff out, and we'll then also print a new line right after to not mess things up. Get rid of this input because that input's not needed anymore. And I guess I have a while loop. I should just do a for loop. For int step equals 0, while step is less than 11. Step plus plus. Guess that's just, yeah, not needed. Let's see. Let's see if this matches. So after 10 steps, do we get the same values? 2, 1, -3. It looks like they are all correct. Cool. All right, so that is the first half of this first part, is tracking their coordinates and velocities. The second half here is what is actually what we're submitting, and that is we have to calculate their total energy in the system, which is actually not too hard to do. And we'll do this up here in this step here. And so because we're actually going to the 10th step and then we're actually doing math on that step, what we have to do is stop one step early, and then after this we output whatever the step is. Does this work in Java? It does, okay. And then after this step, we will go ahead and output one more time. And then right after this, we want to loop through once more to then calculate our energy. So the energy for this is done like so. So the total energy in the system is the potential energy multiplied by the kinetic energy. The potential energy is just the sum of the absolute units of the XYZ coordinates, and the kinetic energy is the sum of the absolute of the velocity coordinates. So again, so this isn't too hard to do. So this will be int potential, and it's going to be equal to x plus y. I know I don't have the absolutes on this yet. And it's going to be then math dot absolute. Math absolute, math absolute. And there. Okay. Easy enough to then do the kinetic. Just swap in the velocities, and then lastly, output the sum is then going to be equal, or it's going to plus equal the potential times the kinetic. And then we will go ahead and output the sum, or so just output part 1 to be sum, and it's 1,000 steps. So this is 10 steps. So let's just make sure that the values are correct. 179, good. So let's go ahead and switch to our input, change steps to 1,000. Correct, yep. And run this. And we get 6678 as our input, submit it, and we got it right. All right, cool. Let me go ahead and read part 2, and I will get back to you guys.